Given the function f, use it to sketch the graph of the function g of x equals 1 over 2 f of x, and h of x equals 2 times f of x. Since the new function is obtained by taking the old function f of x and multiply the entire function with a number, this is going to be a vertical something. Now, if the number being multiplied or the multiplying factor is less than 1 and it is still positive, then the result will be a shrinking for vertical transformation. If the constant multiple is more than 1, then the graph will end up stretching for vertical transformation. And so G is the vertical shrinking of the original graph, and so it will make the graph shorter. And H is the vertical stretching of the original graph, and so it will make the graph taller. For the transformation to be done correctly, the scale needs to be maintained. The shape will be proportional. And so we'll be looking at some of the points that we are interested in, where the graph might change its direction or its shape. These are the points at x equals 0, x equals 1, x equals 3, and x equals 4, or perhaps x equals 2. So those are the special points. The function g will have the function f. And so when x equals 0, f of 0 is 0, and we need to have that. Half of 0 is still 0. When x equals 1, f of x is 1, and we would need half of that, which is 1/2. And so we just simply connect the 2 points. That is part of the function g. Remember that the shape needs to maintain its proportion. When x equals 2, f of x is 2, and again we would need to have that. Half of 2 is 1. When x equals 3, f of 3 is 1, and we need to have it. And when x equals 4, f of 4 is 1, so we will again need to have it. The lat P is still a horizontal line. Now we will still need to connect the middle part, but it no longer looks like a semicircle, but still it is still a round shape figure. This is the graph of the function g. Similarly, the graph of the function h would double the height of the function f. At this point, we notice that it helps if we keep track the table of the value of f of x. When x equals 0, f of 0 is 0. When x equals 1, f of 1 is 1. When x equals 2, f of 2 is 2. And when x equals 3, f of 3 is 1. And when x equals 4, f of 4 is still 1. And so the graph of the function h would double the graph of the function f. And so if we take h equals 2 f of x and graphed it, then we would double the y value of the function f. So to double it, we get 0, 2, 4, 2, 2. We double the y values of the function f here. Alright, so when x equals 0, y is 0. When x equals 1, the new y value is now 2. When x equals 2, the y value is 4. When x equals 3, the y value is 2, and when x equals 4, the y value is 2. Again, we still need to maintain the proportion of the shape of the graph, and so the original graph is linear. It is a line from 0 to 1, and so we will still need to draw the line between 0 and 1 for the new graph. Similarly, from x equals 3 to x equals 4, it is a horizontal line. Now for the middle graph, we do not want to use the line to connect the points there, but we will try to draw a round shape. Again, this time it is no longer a perfect semicircle, but it is still a round shape figure. And this is the graph of the function h. Notice that the graph of the function g will shrink the graph of f. It makes it smaller, and the graph of the function h will stretch the graph of f, and it make it taller.